IoT devices generate vast amounts of data. Whether that data is processed on the edge, a distributed network, or a central server, a process is needed to manage the data stream, the events generated by the devices, and in some cases, trigger actions based on said events. Hello and welcome to the Martini Knowledge Base video series. The use case for this demo is to log an event stream and then trigger an action based on the data contained in those events. The demo simulates an event stream from IoT devices but is equally applicable to any integration using a pub-sub architecture. In this demo, IoT devices generate a data stream of events, representing whether a device is available or in an error state. A message queue receives the event data stream, while a Martini service subscribes to the queue, processes the events, and triggers an action depending on the data in the event. When you start Martini, you'll be greeted with a welcome screen containing demos for integrating systems, building workflows, designing APIs, or creating applications. Scroll down to find and click on Demo 010, Event Processing for IoT. Click Install. When the pop-up appears, simply click on Finish. The package as well as the other packages that this demo requires will be automatically downloaded. The package will then appear on your navigator. Right-click the package and click Start if it hasn't started yet. A green icon will indicate it has started, while a test procedure that you can follow will also appear on your screen. Let's do the test together. First, open the endpoints of the package. For this demo, you'll see we have used a JMS endpoint called Events Queue that listens for messages on the embedded ActiveMQ message broker. Our simulated IoT services will be sending events to this message broker. Note that we could have equally used Kafka as the message broker, and all the other principles in this demo would remain the same. The other endpoint, Event Scheduler, will simulate a stream of events being sent to the broker from our IoT devices. Right-click both endpoints and click Start. The Event Scheduler endpoint will commence simulating events being sent to the message broker by 3 IoT devices. In the real world, these would be physical, running over a remote network. Each device will send a status to the server of either OK or error to represent its current state. In the console, we can see the events are being logged. Each event will be pulled off the message queue by the Events Queue endpoint, and the message itself will be processed by the configured service. The service will inspect the event and compare the status of the device to an in-memory data store. If the status has changed, then the service will write the updated status to a database. Let's take a look at the data being written to the database. Open the SQL query created for this demo by switching to the database's perspective by clicking Database in the upper right and clicking the Queries folder located in Local and Queries. Double-click Demo 010, select All Device Record.sql. Click on the green Run icon on the upper right to run the query. In this table, you can see that the integration logic has written a record to the database when the status of a device changes, going from OK to error and back to OK again. Note how the integration logic for this demo has only written the change of state to the database. If a device has sent consecutive messages with the same state, then the messages would be ignored. This demo has shown how to listen to events on a message broker and to trigger an action based on the data contained in the event. To learn how all of that worked and how the integration was carried out, you can check a line-by-line guide in our knowledge base article. You can get started with Martini for free at torocloud.com. Please feel free to leave a comment, hit that like button if this demo helped, and subscribe to our YouTube channel for more instructional videos such as this one.